Hello and welcome to Mod 13.3, Solving Using Area Formulas. So to kind of give you perspective in the big picture of what we're doing, we've found the area of shapes. Given the dimensions, we use the formulas and we found the area. Now we're going to mix it up a little bit to where I'm going to give you a shape. I'm going to say that the area is equal to 12, and then I'll say that this is equal to 4, and I'm going to have you find that missing piece right there. And so we're going to use area formulas to do that. So let's start by taking a look at some drawings and see how we can work backwards using area formulas. Let's look at this example. We have a parallelogram, and we are told that its area is 72 squared centimeters. Its base is 12 centimeters, and we need to find the height. And so that's the question mark. So in order to do these, we use the area formula. And the area formula for a parallelogram is the base times the height. Now we plug in those numbers. We have 72 is equal to 12, and then we'll put in x for the unknown. We could leave it as h, and we just have to solve for x. And now here's what we got to draw back on our solving skills. We want to get x by itself, and in order to do that, we have to get rid of this 12. That relationship right here between the 12 and the x is 12 times x. So to undo that, we have to divide both sides by 12. So we divide both sides by 12, and we end up getting x equals 6 centimeters. And that's the answer. And so I got a couple more examples where we use different shapes and use different formulas to use the same process. So we plug in the numbers and we solve for the one unknown. So let's take a look at one involving a triangle, because we've got a fraction there. So here's a triangle. It has a height of 8 inches. Its base is unknown, and its area is 80 square inches. Now, what's going to be tricky with a triangle is that its formula involves a fraction. And so the biggest piece of advice I can give you is take your time with this. Don't try to rush it, because when you rush it is when you make silly mistakes that are can so easily be taken care of. So start plugging some stuff in. 80 for the area. The 1/2 stays as a 1/2. Our base is unknown, and our height is 8. Okay, so now the 1/2 and the 8, I can multiply those together, and that ends up giving me 80 is equal to 4 times x. And now I'll divide both sides by 4. Do my work over here. X equals 20. And since we're talking about units, 20 inches. So again, we're using the formula, we plug in what we know, and then we use inverse operations to find the thing we don't know. Let's look at a trapezoid, because that again has a fun little formula. So here we have a trapezoid. We're given the 2 base lengths, and we have to find the height. So again, it helps to recall the formula. Area is equal to 1/2 base 1 plus base 2 times the height. Plug in the numbers that we have. 120 is equal to 1/2 10 plus 14 times h. Now we have to work on simplifying, and so we have all this mess here that we got to work through. Got to make sure we use order of operations, and you might be picking up on a lot of the things that we've studied so far this year are now coming back to be used all at once. How fun is that? So first I got to combine that. 120 is equal to 1/2 times 24 times our height. Now I will take care of these two. So scroll down a little. 120 is equal to 12 times our height. And now that we've reduced it to a number and a variable on one side, we divide by that number because it's being multiplied, so we have to use an inverse operation. And when we do that, h is equal to 10, and that gets us 10 inches. All right, so I got one more example I want to show you. And with that example, we're going to throw in some fractions, because you're going to see a few of those. And I just want to give you fair warning. Fractions can happen, decimals can happen, but it doesn't change anything. So let's draw up a fraction example. So here we have a fraction example. Again, I can't stress to you enough, the process doesn't change. We'll use the formula, area is equal to 1/2 base times height, but we're now just going to use fractions. So plug in the information we have. 3 is equal to the area, so 3 goes into A. 1/2, our base is unknown, so we'll leave that as, or put that in as x. And then our height is 1 2/3. But the thing is, I don't want to write it as 1 2/3. I want to take 1 2/3 and make it an improper fraction. And so that would be 5/3. And so times that by 5/3. All right, now we got to deal with fractions. So what we can do is we can move a few things around. So what I'm going to do is use the commutative property and just kind of flip those two. So 3 is equal to 1/2 times 5/3 times x. You gotta love math, because by the end of the year you start to use everything that we've done all together in one problem. And so all the fraction stuff, the commutative property stuff, the solving stuff, geometry, all right here. Gotta love it. Now, multiplying fractions, you just multiply straight across. So numerators to numerators, denominators to denominators. So 3 equals 5/6x. And this was one of the harder problems I could give you on the previous test, trying to solve that. In order to do it, we need to get x by itself. We multiply by the reciprocal. So let's actually get some space here so we can see what we're going to do. 3 equals 5/6x. When we multiply by the reciprocal, that is 6/5. 6/5. Perhaps you remember the mirror line, so whatever you do on one side, you have to do on the other side. Those 6's, those 5's cancel each other out, and all we're left with is x on that side, which is what we want. Here, we have to multiply. You can't reduce that. 6 and 3 look tempting, but remember that's 3/1, so we have to multiply the numerators and multiply the denominators, and we're left with 18/5. So if you wanted to, you could box it, walk away. That's totally fine. If you want to go one step further, you could make it a mixed number, which would be 3 3/5 is equal to x. Either way is fine. But again, you're going to have a couple problems where you're going to have some fractions. Okay, now we're going to get into the hard stuff, word problems. It's not too much more work, okay? It's just, it's presented to you in a different way. So first, I want to talk about the process that we're going to need with word problems. And the process, the first step is draw a picture. You're not going to get a picture. You're just going to be given words. So draw a picture. Then, step 2, plug in values, or pick an equation and plug in values for the equation. So plug in values. And step 3, you solve. So let's go through 1 or 2 examples, and then that'll be it. All right, and again, you're going to see it's the same thing. It's just that it doesn't always come with a picture. Okay, so let's look at this one. Renee is sewing a quilt whose pattern contains right triangles. Oops, which means it looks like that. So we have right triangles. Each quilt piece has a height of 6 inches and an area of 24 inches squared. How long is the base of each quilt piece? Now, it doesn't matter if this is drawn to scale. This is just to kind of help us sort through the information, because this X may be bigger than 6, all right? And then that would look kind of silly. But, again, it doesn't matter that much. We're just trying to get a feel for what goes where. And so we drew a picture. Next step is we plug in the values into the equation. So area is equal to 1/2 base times height. 24 equals 1/2 x times our height, which is 6. So multiply those together, you get 3. 24 is equal to 3x, and x equals 8. So yeah, it looks, I didn't draw it to scale. That's totally fine. But I did have a picture to kind of help me make sense of the information, and I was able to solve the equation and get the right answer, which is 8. Let's do one more example, and then we'll call it good. All right, in this one we have the cross section of a water bin is shaped like a trapezoid. The bases of the trapezoid are 18 and 8 feet long. It has an area of 52 square feet. What is the height of the cross section? So once we're told trapezoid, we have to draw a trapezoid. Again, it's okay if it's not exactly like the one that maybe it was envisioned. This is just to help us sort our information. We're told the bases are 8 and 18. That we should probably put in the right order. You know, the longer one's 18, the shorter one is 8. We don't know what the height is, so that's the unknown, but we do know the area is equal to 52. And now it's just about using the formula, 1/2 base 1 plus base 2 times our height. And so we have 52 is equal to 1/2 times 8 plus 18 times our height. And then let's see here, so 52 is equal to 1/2 times 26 times our height. And keep on order of operations, you gotta do that first. And now we can do this. So 52 is equal to 13h divided by 13 divided by 13. H equals 4. And then go back, what's the unit? We're talking about feet, so 4 feet. There we go. So today we're just taking what we've done so far and kind of respinning the problem. All right, you have to find the missing area. You have to find the missing dimension. You may be given to it in a picture form, or it's going to be embedded in a word problem like this. But if you draw a picture, you use the formula, you take your time, I think you guys will do just fine. Good luck.